So finally here we'll move to the very last part of the talk. We'll look specifically at the Hylocereeae, which has a number of interesting anatomical characteristics. Beautiful epiphyllum flower here, which is probably what this group of cacti is known for. And you'll see that on those epiphyllums and a lot of the plants in this group, we've got these strange kind of flattened stems. And when you hear a flattened photosynthetic stem, you might think back to an earlier slide in the presentation where I told you that these flattened photosynthetic opunctioid stems are called cladodes. So our question here is, we know this is a cladode, like on this Opuntia basilaris, but is this epiphyllum stem a cladode as well? And so in order to figure that out, we'll take a section, just kind of a rough section here of each of them. We've got a opunctioid here, a tunilla on the left, and on the right here, we have our section of an epiphyllum. One thing to immediately notice is that on our opunctioid, like I said before, that the vascular cylinder or vascular bundles kind of follow the outer edge of that stem, creating kind of an even cortex all around the outside of that stem. But on our epiphyllum here, you can see the vascular cylinder really is just circular in the center, and then this is just all cortex around the these kind of flattened portions of the stem. So is the stem really flattened? We've got a flattened stem here, certainly, because we can see that vascular cylinder is a very distinctive oval. Whereas here, really, even it's a little ovular, but it's mostly circular. And so it's kind of better, you can argue it both ways, but it might be better to refer to these epiphyllum stems as simply a two-ribbed cactus. It's kind of unusual, you know, we're used to five-ribbed cactus or many-ribbed cactus, but here this is a true two-ribbed cactus. Whereas this has no ribs, it's just a flattened photosynthetic stem or true cladode. So we'll move on looking at this Hylocereeae undatus stem, which instead of a two-ribbed cactus is going to be a three-ribbed cactus. And just like I guess the good part about being in Colorado is I can get beautiful pictures of mahuenas. Can't quite get such beautiful pictures of some of these epiphytic cacti. Quite difficult to grow here without a huge greenhouse. So when we look at that three-ribbed stem, this is what we can see. We've got our vascular cylinder, we've got our cortex, we've got our pith, we've got a lot of large mucilage cells in these plants. But we've got these kind of strange, a second circle outside of that vascular, or that wood towards the center. So let's look at those in closer detail. And we actually have fibers. It might sound like kind of a term from the past, and indeed we haven't looked at it since the beginning of the presentation when we looked at Pareschia, the most kind of normal cacti. So at one end, we've got Pareschias, the most normal sort of regular plant versions of cacti. And now we're at some very strange three-ribbed tropical cactus, and these fibers show back up at the very outside of these vascular bundles. And the reason that these plants are thought to have these fibers is because, as you saw in that previous photo of the actual plant itself, these plants have long, pendulous, floppy stems, and they need all the extra mechanical support that they can get. And so they get that in the form of these fibers. So we'll move from a three-stemmed epiphytic cactus now to Selenocereus spinulosus from Mexico and southern Texas. Mine happens to be from southern Texas here. We'll look at a five-ribbed epiphytic cactus. This is what it looks like here. I will say that for this presentation, this is by far the hardest plant to section because the vascular cylinder here has such thick, strong wood, and the rest of the stem is just this very, not very structurally sound and filled with mucilage cells. So trying to get both the mucilage cells and this woody cylinder in the center to section perfectly was very, very difficult. I tried for a long while, and at the end, this was kind of the best I could get. I don't know, you might think it looks great, but to me, little things bother me after, doing it for a while. But this is what our stem looks like. You can see that just like that previous slide, we do have these fibers. This is another cactus with long pendulous stems. And we've got fibers at the tip of each vascular bundle again. And of course, those mucilage cells. But wait a second, this one has these cortical bundles, these vascular bundles in the cortex as well. And they also have fibers. That's very unusual. Here, just you can see some of the things that bother me is these, sometimes when you section a hard tissue, it will curl. And so you can see that these little clusters of fibers are curled up at the sides. But let's look at this little unusual cortical bundle a little bit closer. You can see it looks kind of actually like a hot air balloon. Got the xylem at the bottom here is like a little basket. We've got the rigging here, the phloem looks kind of like the rigging, and then these fibers, this fiber cap looks like the balloon itself. So here we've got our little cortical bundle hot air balloon floating by the mucilage cell sun. So in conclusion, cacti have a diverse anatomy related to the variety of morphological forms that they can take. And really, hopefully with this presentation, you have seen cacti from a totally different perspective from the inside and just what those cells that form these beautiful plants look like. The science of plant anatomy here actually has quite an old-fashioned reputation, and that's deserved because many of the methods that I've used in this presentation, I use for my research, and people use all over the world for plant anatomy, remain relatively unchanged since Victorian times. But despite this, there's still a lot of exciting research that hasn't been done yet, and so it's very exciting as well. It's a fun bridge between both the past and the future. Just to kind of show you how maybe old-fashioned plant anatomy can be, this is the oldest slide in my collection. It is just a cactus epidermis, and it was made in 1864, which for those of us in America was the Civil War times. And this slide is perfectly usable today. So hopefully the slides that I've made that you've seen in this presentation will be around 150 years from now as well. Just a couple thank yous. None of the slides that you've seen in this presentation would be possible without a generous grant from the Colorado Cactus and Succulent Society. I would also like to thank Dr. Lemke, my advisor at Texas State University. And I'd like to thank Gunnar and Roxy from the CSSA for reviewing the presentation and offering comments. Like I said at the end, there's still a lot of exciting research to do in plant anatomy, some of which I guess hopefully it's exciting for other people, but it's definitely exciting for me. I'm looking at cactus extrafloral nectaries, and there is still a lot of material that I would like to look at as part of my research. So if anybody has young stems of either Armatocerus or Pachycerus, or if you happen to have a blooming Stenocerus or a blooming Leptocerus, I've got my email and my Instagram there. I'd be happy to cover shipping costs, and I would love to get some of that material to look at as part of my research. Finally, that's the end. Like I said, I hope everybody was able to see cacti in a little different way and enjoyed the presentation. And of course, learned something too.